Great. So now we have our recording started. My name is Kat Fribley, and I'm the executive director here at Birdability. And we are delighted to be working together with Martha Steele, Jerry Barrier, and Donna Poissant, who are the intrepid planning team for the Blind Bird-a-Thon. Our second year is coming right up. Our event is May 3rd and 4th this year. You can participate on either of those days. And we are really thrilled to say that we have moved global this year. This morning, Martha and I had a conversation with some birders from South Africa. We know we have folks who are participating from Chile, from Venezuela, from the UK, from Mexico, from Canada, from the US. So it's going to be an exciting sophomore effort this year. I want to remind you have a website. I'll drop it into the chat in a little bit that has a lot of resources, both for individuals who are interested in participating as part of the Blind Bird-a-Thon, and also for organizations who might be interested in creating events or opportunities to support blind birders and the organizations that are serving them in their communities to be able to participate meaningfully in the Bird-a-Thon this year. I am going to just honestly say I am so grateful you're here. If you are who might benefit from captions, please feel free to hit the CC button at the bottom. And when you do that, it will allow you to have captions enabled. Please feel free to do that if that will help your access to this conversation. I am going to turn it over to Martha Steele, and I'm going to sit back and enjoy, Scott, your presentation. So thank you all for being here, and away we go.
Thanks, Kat. And I'm Martha Steele. I'm going to introduce Scott and then let Scott take it away. I've known Scott, I think I ran into him in Wisconsin. Oh my goodness, 20 some odd years ago. Scott is a very well-known, noted author, naturalist, field researcher, and he has written a number of books, and he's written countless articles for many publications. It's the book's most relevant probably for tonight. In 1999, he published a book, Living on the Wind, Across the Hemisphere with Migratory Birds. And this was a book that was nominated as a finalist for the Pulitzer Prize. And more recently, in 2021, he published a book, A World on the Wing, The Odyssey of Migratory Birds. In my mind, Scott is really has no peer in terms of his knowledge and understanding of bird migration, but his writings are just exquisite, folks. If you ever get a chance to read his books or any of his articles, he's just an unbelievable writer. Very engaged and very easy to understand for the lay audience, and just beautifully, beautifully written. And above all, and perhaps most important, Scott is an incredibly wonderful human being. And he's very, very passionate about birds, conservation of birds, conservation of the environment, climate change. He is passionate about leaving the world for all of us, humans and animals, other animals, plants, better than when he left it, when he came in. So he is really just an absolutely wonderful person. So, and he's a fantastic speaker, as you will discuss, as you will find tonight. So without further ado, Scott.
Well, thank you. And let me just say, first of all, that's a very high bar to live up to. And second of all, Martha Steele is one of my heroes and has been for a very, very long time. And so she would have had to beat me off with sticks after she asked me to do this. I jumped at the opportunity. Anything I can do to assist anything that Martha is doing is great. So it's a pleasure to be here this evening. It's nice to see some other old friends on the call. Looking at you, Diane. It's been great. And talking about birds and bird migration is not a hard thing for me to do. I've been messing around with birds most of my life in one way or another. Started to get hooked on raptors as a kid growing up in Pennsylvania, and been doing, gosh, snowy owl research and saw-whet owl research and hummingbird research and all kinds of stuff over the years, which ain't bad for a college dropout, I guess. But anyway, I've also been really fortunate to have spent a lot of time with with folks who have a much deeper understanding of bird migration than I do. Opportunity to do field research with some really extraordinary scientists, and I've picked up more or less by osmosis from them. I think a decent understanding to the extent that we do understand how birds migrate. And the thing is, there's still an awful lot we don't know, and we'll touch on some of that this evening while I'm talking. So I guess maybe the best way to start is just to ask, the fundamental question is, why do birds migrate? And I think if you ask the average person on the street, they will tell you some form of, well, in the winter, it gets cold, and these birds have to get away from the cold because they're going to die if they get too cold. And the fact of the matter is, birds can take the worst weather this planet can throw at them with a shrug. I mean, you think about emperor penguins breeding in the middle of the Antarctic winter. Cold weather does not hold any particular threat to birds as long as they get enough to eat. And the most highly migratory species are, for the most part, those that depend on either seasonally abundant food supplies like insects or fruit or nectar, or else seasonally available habitats like open water. We were just, before this all started, Kat and Martha and I were talking about waterfowl, and the waterfowl are pouring back north. A a goose in the middle of a lake is safe from bobcats and coyotes unless the lake freezes, in which case it becomes literally a sitting duck. So they have to move south to find that safe open water. Um, but it's not that birds can't survive in cold places. And of course, you have huge numbers of birds, even in the far north, that remain there year round. And we'll get into a little bit later, we can talk about like different migration strategies, how some birds, it's not a one size fits all phenomenon. Um, but when you think about the numbers of birds coming north, like for example, I live in New Hampshire, and it has been a very cold, very snowy winter here in New Hampshire. And the millions and millions of birds, migrant songbirds that are here in the summertime, warblers and vireos and Tyron flycatchers and thrushes, they're all gone. They're all down in the tropics somewhere for the winter. Not because there isn't food here, but there just isn't enough food here through the entirety of the winter. But we still have insect-eating birds like kinglets and creepers, and birds like chickadees that depend very heavily on insects during the winter. There's just not enough insects in the forests of the north during the winter to support the literally billions of insect-eating birds that it's able to support in the summer. So those birds move south. So different kinds of migration. So um, one of the birds that I really look forward to having back here in the summertime are black-throated green warblers. We get lots of black-throated green warblers. They have this really wonderful, bee, 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 zee, 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 zo, zee, 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 zo, zee song. Um, those birds spend the winter in Mesoamerica. Right now they're down in the highlands of Mexico, northern Central America. Um, all of the black-throated green warblers that nest in North America depart North America and fly down into the tropics. And that form of migration, where you have a distinct breeding range in the north and a distinct non-breeding range in the south, usually in the tropics, where all of the birds, all of the individuals of that species leave from one range and go to the other. That's called complete migration. And when most people think of migration, that's what they're thinking of. They're thinking of complete migration. Except that not all birds do that. And there are many, many species of birds in North America, in the Northern Hemisphere in general, where some regional populations are migratory and others are not. Some populations may be more highly migratory than others. Some may fly a relatively short distance, others may fly a very long distance. Some individuals, some populations may be completely non-migratory. They may not migrate at all. And so you have a lot of overlap between the breeding areas and the non-breeding areas and the migration areas. And the term for that, and I have to tell you, this is my least favorite term in ornithology, is called partial migration. I have no idea how you can partially migrate. This the dumbest. It's nobody asked me, they didn't come to me about this. Um, but let me think about red-winged blackbirds, red-tailed hawks, blue jays. There's so many different species of birds, great blue herons, where you have bald eagles, different regional populations that migrate. Some do, some don't. And then you have birds like, um, oh, downy woodpeckers, northern cardinals, great horned owls, that are essentially resident, that move out from, their parents' territory as a chick, they establish a territory of their own, and they remain there for the rest of their life. Now, sometimes we'll see with some of those birds that you'll get, kind of a pulse of birds moving a relatively short distance. For the most part, they're resident for the rest of their lives. And then you get the birds that are completely unpredictable. And these are the ones that birders really get excited about, the so-called eruptive migrants. And that's eruptive spelled Irruption, not eruption eruptive like a volcano. It means eruptive means a rushing in rather than an exploding out. And these are birds like a lot of the northern finches, like crossbills and purple finches and evening grosbeaks and oh goodness, and red poles. Those are all examples of eruptive birds where they're content to stay up on the breeding grounds in the north as long as they get enough to eat. But every once in a while, the food population, the food base collapses. And with those birds, it's generally a lack of conifer cones. Some years the spruces and the pines and the hemlocks and the firs are heavy with cones, and there's lots of seeds for these birds to eat. And other years, the trees turn off the tap because it's a good way of reducing the number of birds that are eating your babies, because that's what those seeds are. And when that happens, and that happened this year here in the Northeast, where there was very little food up in the Northeast, and a lot of those birds go rushing south. And so it was a big winter finch year in many parts of the Northeast and the Mid-Atlantic, because a lot of these birds that breed up in the boreal forest of Canada were more or less forced to fly south to find food. We also see eruptive migration with some species of raptors. Um, Northern hawk owls are a good example, boreal owls, great gray owls. And the kind of classic eruptive migration are birds like great grays and northern hawk owls that move south en masse when the small mammal populations on which they depend drop. And it's either fly or die. And so they'll move south until they find a place where there is an abundance of prey. They don't know where they're going. They've never been there before. They'll probably never come back again. I remember back in the early 90s, the first northern hawk owl to show up in Pennsylvania in more than a century showed up at this little farm up in the Pocono Mountains at the end of this long dirt road. And man, people came from all over to see this thing. And the landowner was not stupid. He set up a hot dog and hot chocolate stand at the end of his driveway. And I went up a couple of times to photograph this bird, and I got to know the guy. And he grabbed me one day and he said, "Hey, listen, I got a daughter in college." He said, "This bird's coming back next year, right?" And the sad fact was, no, that bird was going back up to the subarctic and probably never came south again. That's the charm and the excitement of these eruptive migrants is we never really know where they're going. The other thing about migration that I think the average person assumes is that it's a north-south event. These birds are flying north in the spring and south in the fall. And the fact is they are ping-ponging all over this globe like pinballs in a pinball machine. And the distances they travel are really extraordinary. I mean, the most astonishing migrants of all are the pelagic migrants. These are the pelagic seabirds like albatrosses and storm petrels and shearwaters and petrels that can traverse tens of thousands of miles on their migrations every year. In fact, some of these birds, like lace and albatrosses that breed in the Hawaiian Islands, a grocery run for them when they're raising their chicks is to go from Hawaii all the way up into the Bering Sea and loop back down again, like 4 or 5 thousand miles over the course of 2 weeks, just to go bring back food for your kid. Um, so they're extraordinary distances and in every conceivable direction. Just earlier today, I was on a call with a couple of colleagues of mine that I've done field research with in Denali National Park up in Alaska. We were studying the migration of Swainson's thrushes up there. But Alaska is an extraordinary place because the birds that breed in Alaska literally fan out over 3/4 of the Earth's surface on their migration. We can, when we're tagging birds in Denali, we may catch Swainson's thrushes that travel 9,000 miles to the border between Argentina and Bolivia for the winter, or we can find Arctic warblers that travel to Borneo or the Philippines or parts of Southeast Asia. Birds like long-tailed yagers that spend the winter out in the middle of the Pacific Ocean. So, these birds are just exploding across the world. And I guess that kind of brings up the next big question, which is how did it all start? How did migration evolve? And we weren't there to see this. So there's a fair bit of speculation in this. And there's actually been kind of an argument going on for a long time among scientists who study migration. Did migration start with birds in the tropics moving north and then going back where they came from? Or did it start with birds in the north being forced south and then coming back north again? And of course, when you look at the map of the world, the vast majority of land area is in the northern hemisphere. So we're mostly talking about birds leaving the northern hemisphere and going down into the southern hemisphere. Although there's definitely austral migration in places like Asia and southern South America. But this tension between where basically the chicken and the egg, where did migration start? The latest analysis, and this kind of upended what my thought was about migration for a very long time, suggests that most migrant groups got their start in the north and moved south, and kind of some of them dropped off in the tropics, that they just stopped migrating and began to diversify. And today, if you look at whether we're talking about vireos or tyrant flycatchers or thrushes or orioles or tanagers, they're by far more diverse in the tropics, which sort of initially suggested that those families may have originated there. But instead, it looks like it was the other way around. They probably were in the northern hemisphere. And of course, over the last 2.5 million years, we've had 20 expansions and contractions of glacial ice. There wasn't just one ice age, there's been 20 ice ages. The last one ended 15,000 years ago. And as that glacial ice retreated, what we have seen, and we can still see this happening today, birds moving farther and farther and farther and farther north each year, and then going back to their wintering grounds down in the tropics. We can also see in real time the evolution of new migratory routes as birds get sometimes blown off course, more often than not, just simply birds born with a little bit of bad software. Migration is genetically encoded. Most birds are born with it baked into their DNA to fly in a certain direction at a certain time of the year for a certain length of time. It's not a conscious decision. A wood thrush doesn't wake up one morning and say, I've heard Guatemala's great this time of year. Um, and anytime you have something that is genetically coded, it is subject to mutation. And what we've been seeing, and this is something I've been involved in for about the last 25 years, more and more species of Western hummingbirds, like rufous hummingbirds and Allen's and calliope hummingbirds, that instead of following their normal migration route out of, let's say, a rufous hummingbird born in southern Alaska, you should be flying, according to what rufous hummingbirds have always done, you should fly pretty much due south and spend the winter in the mountains of Mexico. Except that some rufous hummingbirds are born with a hiccup in the software. And instead of going south, they take a left turn and they go east. And we've been seeing an increasing number of these birds showing up in quote unquote the wrong place at the wrong time of year. But they end up down on the Gulf Coast, which is not a bad place to spend the winter, and they survive and they fly back to their breeding grounds the next year and they pass on those supposedly maladaptive genes to the next generation. And so what we've seen in the last 30 or 40 years is an explosion in the number of purportedly Western hummingbird species now wintering in the southeastern United States. We're seeing the evolution of a new migratory route. And I just find that incredibly exciting. So some of this is speculation. Some of it is we can see it with our own eyes, how these birds are adapting and changing and constantly shifting. Um, and they go amazing distances. I mean, this is to me one of the most astonishing things about bird migration, the distances that they go. I mentioned pelagic seabirds that, will travel, like short-tailed shearwaters from Tasmania will travel 44,000 miles over the course of their non-breeding season, all the way up into the Bering Straits and all the way back down to Tasmania. Um, One of my favorite places on Earth is a little tiny island off the coast of Maine called Eastern Egg Rock. That's a puffin colony. It was the first restored puffin colony in the world. And on that island, there are several thousand terns that breed, including Arctic terns. And a couple of years ago, my colleagues and friends at the National Audubon Society put little tiny tracking devices called geolocators on Arctic terns breeding on Eastern Egg Rock. And they sent these things off. These aren't transmitters. All they do is they record data. And when the bird comes back the next breeding season, you take the geolocator off and you download the data and you can find out where the bird went. And they discovered that those Arctic terns were flying up to 61,000 miles a year. Some of them were looping around the bottom of Africa all the way up into the Indian Ocean. And this is a bird that's about the size of a mourning dove. So not at all a big bird, but absolutely global in its expanse. Probably, though, for my money, the most amazing migration of all, and certainly the longest nonstop migration of a land bird that we know of, is a bird called the bar-tailed godwit, which is a pretty good-sized shorebird, one of the larger shorebirds, about the size of a pigeon, basically. Long, skinny legs, a long, straight ice pick of a bill. And bar-tailed godwits breed across Eurasia, but there's a population that has colonized across the Bering Sea into Alaska, into western and northern Alaska. And every year in late August and early September, all of those bar-tailed godwits gather along the shores of the Alaska Peninsula. And they undergo a phenomenon called hyperphagia, which is basically it's binge feeding. They just eat and eat and eat and eat and eat and eat and eat, feeding on these marine invertebrates, macroinvertebrates, small mollusks in tidal flats. And in the course of a couple of weeks, they more than double their weight. They are 55% fat by the time they're ready to fly. They're the fattest wild birds anybody's ever documented. And in fact, it's crazy. If you pick them, they feel squishy in the hand, like it's like holding a water balloon. Um, and they are preparing for, as I said, the longest nonstop overwater crossing of any bird on Earth. And so, having gained all this weight, um, there's a number of physiological changes that are happening in their body. They've ballooned up in weight. Without exercise, their flight muscles, their pectoral muscles in their chest increase by 30 to 50%. Their heart rate, their heart mass, their heart muscle mass increases by about 50%. They get ripped and buff without exercise. I would really like to sign up for that pill. Um, and having gained as much weight as they possibly can in a very short period of time, they no longer need their digestive system, so they get rid of it. In a matter of days, their stomach, their intestines, to a lesser extent, their liver and kidneys shrink dramatically in mass. While, like I said, their muscles are getting, so they're beefing up their muscles, they're shrinking their digestive system, and then they take off and they fly 8,100 miles nonstop across the widest part of the Pacific Ocean. It takes them anywhere from 7 to 11 days of continuous powered flight. If they stop beating their wings, they will plunge into the ocean and they will die. And the astonishing thing is there's essentially no records of these birds stopping on any of the islands in the South Pacific. They overfly Hawaii, they overfly French Polynesia, they go all the way to New Zealand and the coast of Australia, where they land, regrow their guts, and spend their non-breeding season in the austral summer down there, feeding on marine invertebrates and all those good things that are in the Firth of Thames and some of these other big wetland areas on the North Island of New Zealand. And then at the end of the austral summer, when you get into March and April, they undergo the same thing again. The whole process starts over again. Hyperphagia, balloon up in fat, um, guts shrink down, muscles get big, but they can't fly back the way they came because they were able to make that flight because they had prevailing tailwinds that had helped carry them south. So instead of flying from northeast to southwest across the Pacific Ocean, they fly from southeast to northwest to the Yellow Sea between China and the Korean Peninsula. Land, regrow their guts, eat frantically for several weeks, guts shrink down, muscle mass increases, and they fly another 4,000 miles back to Alaska. So 8,100 miles down, 6,000 miles from there to the Yellow Sea, 4,000 miles back to Alaska. They're doing about 18,000 miles a year. And this is a bird that can live 25 or 30 years. So by the time a bar-tailed godwit dies, it has flown the distance from here to the moon and most of the way back again. And I just find that astonishing. But, even relatively small migrants do amazing things. So, um, one of my favorite birds, one of my favorite boreal birds, which is a species we studied up in Denali, are blackpoll warblers. There's millions of blackpoll warblers across the boreal forests of Canada and the United States. They're about 4.5, 5 inches long. They weigh lean weight about less than half an ounce. I like to say you could mail two of these things anywhere in the country for a first class stamp. And they make an extraordinary journey. So the birds that we were studying in Western Alaska, or in Central Alaska rather, when their migration starts in September, they will make one or two nonstop flights from west to east across the entirety of Canada, across Alaska and Canada, and they'll stage up in the north on the northeastern coast of North America. And again, food is essential. So they'll land, they'll feed for anywhere from several days to several weeks, balloon up in weight. Lean weight, they weigh about 12 grams. So that's like what, zero point 0.4 ounces. By the time they're ready to take off, they've gained 20 grams in fat. So proportionally, even more fat than the bar-tailed godwits do. They weigh like more than an ounce each. They're just, if you blow their feathers aside, their skin is stretched tight across this, you know, kind of gross fat. But they need that fat because they're going to take off from the northeastern coast on a night of strong northwest winds after the passage of a cold front. And that will blow them out into the western Atlantic Ocean. And they will be in flight for the next 3 days. This tiny little bird beating its wings something like 4 million times and burning up that fat. And by one calculation, if they were burning gasoline instead of fat, they would get 720,000 miles to the gallon, which is the definition of fuel economy. I mean, my wife's got a Prius. She's very happy with that. She's very like it's nothing at all compared to a blackpoll warbler. Um, so they're going these incredible distances. Now, the majority of our migratory birds leaving North America, especially the majority of our neotropical songbirds, are not going that far. Um, Most of our migratory songbirds are wintering either on the islands of the Caribbean, especially the islands of the Greater Antilles, or from southern Mexico down to northern Central America. That's kind of where the vast majority of them are going. Now, there are other species that head farther south. Red-eyed vireos go down deep into Amazonia. Eastern kingbirds go down into Amazonia as well. And in fact, will kind of move with the seasons across the Amazon basin following the ripening of local fruit supplies, because Eastern kingbirds, which in the summertime up here in North America are highly territorial fiercely aggressive, entirely insectivorous birds. The moment they get into South America, they become highly gregarious fruit eaters in these enormous flocks of hundreds and hundreds and hundreds of them. So you get this like Jekyll and Hyde change with some of these birds from what they're doing when they're on the breeding grounds to what they're doing down south. And there are some birds that continue all the way down into southern South America. Swainson's hawks from the prairies of western North America, they travel all the way down to the pampas of Argentina. Again, 18,000 mile a year trip, just an extraordinary trip. Um, it's the distances are really remarkable. And I mentioned earlier about birds dropping out of migration and how that may be um, how these tropical populations started. We've actually just seen that happen within the last 20 years with barn swallows, because barn swallows are one of these species that travel all the way down to Argentina for the winter from North America. And about 20 years ago, a group of barn swallows near Buenos Aires just kind of said, screw it, I'm not going back. And they just stayed there and they started breeding. And they've created this new tropical, neotropical austral population of barn swallows, which is just, again, just so cool to see this happen in real time. Um, let's see, I wrote some notes to myself here. So I talked about food and refueling. It's impossible to overstate the importance of these staging areas and refueling spots for these birds. Migration is impossible if the birds don't get enough resources at each end of the trip and at points along the way. And ornithologists are a funny group. A couple of years ago, a friend of mine named Dave Melman, who worked for the Nature Conservancy, um, came up with a ranking system for stopover habitat for migratory songbirds. And he called them fire escapes, convenience stores, or five-star hotels. And his point was that when these birds are migrating, they have to make decisions on where they stop. And having all of those different levels of resource available for these birds at different points in their migration is critical. I used to go down every spring to the Gulf Coast in Alabama at a place called Fort Morgan, which is on the east side of Mobile Bay. And in the springtime, you get these enormous waves of hundreds of millions, well, I mean, cumulatively billions of birds crossing the Gulf of Mexico night after night after night during the spring migration coming up from the Yucatan Peninsula. And my colleagues and I we were banding birds down there. So we'd string these mist nets in the woods and we'd wait for these days when these birds um, would come down on the Fort Morgan Peninsula in large numbers. And frankly, most of the time it's kind of boring because if you have south winds coming across the Gulf, which is what these birds are taking off with, they're taking off with these tailwinds pushing them north, it's a relatively easy 22 hour flight for those birds. They don't even break a sweat. And when they reach the coast, you know, Fort Morgan's it's nice. It's a sandy peninsula. There's some forests there, but it's no great shakes if you're a hungry bird. But to the north, on the other side of Mobile Bay, you have these enormous bottomland swamp forests that are like a five-star hotel for these birds. So they would just overfly us and go for the five-star hotel. But every once in a while, the weather conditions were such, either a cold front had come through overnight and these birds ran into suddenly headwinds and rain and lowering barometric pressure. And instead of a relatively easy 20 or 22-hour flight, it's like 25, 30, 40 hours pushing through these headwinds, trying to get across the Gulf of Mexico. And when that happened, when they looked down and saw Fort Morgan, it's like, hello, baby, there is a fire escape. I need to use that right now. And that's a phenomenon called fallout. And it is an extraordinary thing to experience because the woods that had been completely empty of birds the day before are just seething with birds. There is this constant motion and movement and sound of thousands and thousands of exhausted, hungry birds that have come pouring out of the sky. Um, and they don't really care about you. I've had Blackburnian warblers land on the bill of my cap and sit there um, picking off mosquitoes that were coming in to bite me because they were just too tired to do anything else. So, these birds are they're looking for the right habitat, but sometimes you take whatever, any port in a storm, basically. Um, let's see, we talked about physiological change. Oh, so let's the other thing about physiology and bird migration, and this is where we're going to veer into what's going to sound an awful lot like science fiction, but I swear to you, this is real. This is real science, um, which is how do birds find their way? So I I am not an academically trained scientist. I dropped out of college my junior year of undergrad, never went back and finished it. Um, but the semester before I dropped out, I took a marvelous course in ornithology at the last seat in the last session that was taught by a wonderful professor, a guy named Samuel C. Gundy, former B-17 bomber pilot from World War II, former German POW. And in those days, we were taught that we knew that birds had, scientists knew that birds had several orientation cues to help them find their way. In the 1960s, a father-son team had figured out that birds are using not the, they're using the night sky. Now, they're not using the pattern of the stars in the night sky. They're not like the ancient mariners, they're not looking up and going, okay, so the giant W is Cassiopeia, so that means I make a left. They're aware of the apparent rotation of the stars around Polaris. But of course, on a clear night, that gives them their compass directions. They can figure out where north, south, east, and west are. Of course, some nights it's cloudy and that doesn't work so well, but birds have a whole series of fallbacks. I mentioned pelagic seabirds earlier, like storm petrels and albatrosses. Leach's storm petrels that nest by the millions on Baccalieu Island off the coast of Newfoundland find their way back to Baccalieu Island from their non-breeding grounds in the Southern Ocean around Antarctica by smell. And albatrosses, shearwaters, petrels, they all have a really highly developed sense of smell. And in fact, those Leach's storm petrels, which are about the size of a barn swallow, they're very small seabirds, um, they find their burrow among 4 million other burrows by how that burrow smells in the dark. Um, Birds are just incredible, absolutely incredible. Um, so, diurnal migrants like hawks and swallows are using the position and movement of the sun across the sky. And there's also a band of polarized light that they can see, but we can't see that moves like 90 degrees in lockstep with the sun, which is visible even through the clouds. So they have all of these ways of keeping themselves oriented in the landscape and able to navigate. And orientation and navigation are two different tasks. Um, Orientation is how they know compass directions, north, south, east, west. Navigation is a map sense. It's figuring out where you are as you're moving across the landscape and compensating for outside pressures like crosswinds. One of the most mysterious of a migratory bird's senses has always been its magnetic sense. We've known since the late 19th century that birds can sense the Earth's magnetic field. And again, when I was taking ornithology in the late 1970s, we were taught, it was in the textbooks, that birds had these little deposits of magnetic iron crystals called magnetite, either at the base of their skull, the base of the bill, in the brain, sort of scattered through their, varied from species to species. And the assumption was that this functioned like a compass, that kind of pulled their nose to the north somehow, that they were able to detect the Earth's magnetic field. But there were some problems with that because, for example, um, if you expose birds to wavelengths of red or yellow light, they lose the ability to orient magnetically. So it seemed from the beginning that there had to be some visual component to magnetic orientation in birds. And in fact, there was a German scientist, a fellow named Klaus Schulten, who back in the 1970s proposed a way that this could work. And he proposed that in the eyes of migratory birds, in the retinas of eyes of migratory birds, that there might be a photosensitive pigment that would allow the bird to somehow see the Earth's magnetic field. And so he wrote up this paper, pretty dense physics. He sent it off to an American physics journal, which promptly rejected it. in a pretty insulting way, actually. The rejection letter didn't mince words, said that a less bold researcher would have consigned this to the wastebasket. Well, it turns out Klaus Schulten was absolutely right, and it only took about another 30 years to show that. So let's say for the moment that you are a summer tanager leaving the Yucatan Peninsula. You're going to fly across the Gulf of Mexico at night because most bird migration occurs after dark. The air is calmer, it's cooler, there are fewer predators. You've got the night sky overhead to help you orient. As that bird is flying through the night sky, a photon of light emitted, I don't know, 100 million years ago from a distant star enters the eye, strikes the retina, and it hits something called cryptochrome. Cryptochrome is a pigment protein, and the eyes of migratory birds are packed with cryptochrome. And of course, it's not just one photon. This is happening trillions of times a second in the eye of this bird. And and this is where it gets weird because now we're talking about quantum mechanics, and it's hard to talk about quantum mechanics without sounding like you've lost your mind. So in that cryptochrome protein, the photon hits a molecule, knocks an electron off that molecule onto an adjacent molecule. These two molecules are now linked. They are, in quantum terms, entangled. And according to quantum theory, if you were to somehow be able to move those two molecules anywhere in the universe, what affects one would instantaneously affect the others, regardless of distance. They are essentially one thing. I do not purport to be able to explain that because I am not a quantum physicist. But what it also does, just for the briefest fraction of a second, is it magnetizes that cryptochrome protein. So you now have a magnetically sensitive pigment in the eye of the bird. And so as that summer tanager is flying north across the Gulf of Mexico through the night, it is able to see the Earth's magnetic field. I cannot imagine what the Earth's magnetic field is like. None of us have any idea what the birds can see. And in fact, the scientist who's been doing most of the work on this, a guy named Heinrich Mortensen from Germany, um, he and I were both on the Radiolab podcast from WNYU or WNYC last fall. And the producer kept pushing him and pushing him and pushing him. I'm like, what do you think it looks like? And he's like, I'm a scientist. I don't want to speculate. And he finally said, it's probably just a smudge in their eye, but it allows them to keep that north-south orientation. And the cool thing is that at some point in the next, not all that long, the Earth's magnetic field is going to flip. The North Pole is going to become the South Pole is going to become the North Pole. This happens about every 100,000 years. And it won't matter to birds because they're not using the polarity of the Earth's magnetic field. They're just aware if they're going from the equator toward the pole or from the pole toward the equator. So they've got this kind of foolproof magnetic orientation system. So that gives them north-south. They also need east-west, or they're going to drift off course. And there is a magnetic sense there, but we don't know where it lies yet. That's still a bit of a mystery. It may be in the trigeminal nerve that runs through the upper mandible of the bird's beak, but we're not really sure. Oh, I could talk about so much else, but I think I have talked long enough here. I am happy to try to answer questions, and I will try to be, I'll try, I will try to be concise about it because, as you can tell, once you get me going on this stuff, I just don't know when to shut up.
Scott, this is Martha.
Yeah.
Wow. That was wow. Especially that last part. That's something I hadn't I didn't really know about that. And um, just a very quick question. Do all birds possess that capacity?
So we suspect that most migratory birds do. They haven't checked all of them, but the ones that do now, chickens, maybe not. And the other interesting thing is that like for example, homing pigeons, um, different populations of homing pigeons will rely on different orientation and navigation cues. For example, there was a guy named Charlie Walcott at the Cornell Lab of Ornithology back in the 50s and 60s. He did a lot of early work with on bird migration and especially magnetic reception in homing pigeons. And he would actually like strap a bar magnet to the back of a homing pigeon, and the bird would get confused and it couldn't find its way back to its loft. They have these little things called Helmholtz coils that look like a dunce cap sitting, like produces a little magnetic field on the head of the bird. Um, and yet they tried that with pigeons in Italy, in Rome, and they came back with no problem. But when they severed the nerve endings in the bird's nostrils so it couldn't smell, they couldn't find their way back. So the pigeons in Rome, and Charlie Walcott's joke on this was that, well, obviously Rome smells worse than Ithaca, New York does. That the pigeons in Rome had learned to use smell to get back
Yeah,
to their loft, whereas those in Ithaca um, were using magnetic reception.
magnetic field. Yeah,
Yeah.
that's interesting. Okay, so why don't we open Cat? You can kind of monitor.
You bet. Yeah.
Uh,
Can I just say, if folks have questions, you're welcome to put it in the chat if that works for you. If that doesn't work for you, please feel free to raise your hand or to come off mute and let us know that you have a question. We would love your questions for Scott. I have one,
What's
Scott,
that,
if
Cat?
I could ask. Okay.
Wait.
So you talked about uh, the sort of theory about birds, whether they went north to south, or like when migration started, or
Mhm.
south to north, and you said, now it's sounding like this. How in the world do you all figure those things out?
Well, first of all, I didn't figure that out. In
Okay.
fact, it's funny. I was just rereading the paper today to kind of prepare myself for this. It was a case of a number of ornithologists looking at more than 800 species of migratory birds from around the world, and essentially trying to create a model based on what we know about the genetics, what they know about the migration routes, what they
Mm,
know about the geologic history of the areas where these birds are coming from. And I wasn't part of it, and some of the math went right over my head because that's the reason I didn't get a biology degree is because I can't do math. Um, but
mhm,
the consensus was that for the most part, the more likely explanation is what they call the northern home theory as opposed to the southern home
mm,
theory. And I have to tell you, I was pretty invested in the southern home theory. I thought that was the
mhm.
one that made the most sense. But here's the thing about science: when you get if there's new information, you change. If the facts appear to change, you got to change your mind.
Right.
You don't want to be the person they're talking about where they say that, science advances one funeral at a time.
Oh, right, right. Nancy, I see we do have a hand up. Nancy, would you like to ask your question?
Yes, please. Hi. Scott, first of all, thank you so much. What a fantastic
Well,
presentation.
thank you, Nancy. I appreciate it.
I really enjoyed it a lot, and I can't wait to read your book or your books. You have several.
Yeah.
Hmm.
I wanted to ask, this is probably too big a question, but is there a kind of in a nutshell answer or just a kind of macro view answer about how climate change is affecting
Mm.
migration for birds?
It is it's yeah. It is affecting every moment of every migratory bird's every moment of every day through the entire life cycle of every migratory bird on the planet, um, to a greater or lesser degree, just depending on where they are and where they're going. Um, One of the things that we're seeing that in some parts of the world has really been cataclysmic up to this point is what's known as a phenological mismatch, where if you live anywhere, particularly in Eastern North America, you've seen how the seasons are galloping ahead. Most years, spring is coming earlier and earlier and earlier than it did. It's getting warmer and warmer. Um, the trees are leafing out earlier, the insects are emerging earlier. Um, if you're a bird that winters in the southern United States, like a fox sparrow wintering in Georgia, you can tell whether it's an unusually cold late winter, in which case you might just stay there at that feeder in Georgia a little bit longer, or if it's an unusually warm early spring, in which case you may fly back to your breeding grounds in the Canadian boreal forest earlier than would be the case. On the other hand, if you're a Blackburnian warbler wintering in the highlands of the Colombian Andes, you have no idea whether it's an unusually late winter or early spring up here in New Hampshire, where our Blackburnian warblers come back every year. So what we're seeing, because migration is genetically coded, these birds, it's it's proving to be difficult for these birds to adapt quickly enough to the rapid changes that we're seeing in the climate. And so what happens every year on average is these birds are falling a little bit farther and a little bit farther and a little bit farther and a little bit farther out of sync. And it's not that they're not moving up their migration, their arrival time. What what we can see with radar in particular, and with some of the new tracking technologies, is that these birds come across the Gulf of Mexico. They hit the southern United States, whether we're talking about, in the desert Southwest or along the Gulf Coast or Florida, and they kind of go, holy crap, it's late, and then they accelerate from there
Mm.
and they race forward. I have friends that have been banding birds for Powder Mill Nature Reserve. They've been banding for more than 50 years in southwestern Pennsylvania, and they know when, for example, when wood thrushes traditionally arrived, and also because they breed there, when they started breeding, when the first eggs were produced, when the first chicks started leaving the nest. And what they found is that the wood thrushes are arriving in terms of the seasons later and later and later and later. And instead of showing up 2 or 3 weeks ahead of time and having time to recover from their migration and rebuild their fat reserves before they start the really exhausting um, job of raising babies, they're coming back and like, boom, immediately,
Mm.
got to build a nest, got to lay some eggs, because if we don't do it right now, by the time our chicks are at their hungriest, all of those caterpillars in all of those newly leafed out forests are going to be gone, and we won't have enough to feed our kids. And that's not theoretical, because we actually saw that happen from like the late 80s through the early 2000s with a trans-Saharan migrant from the old world called the pied flycatcher that winters in tropical Africa and breeds in the oak forests of Central Europe. And they had fallen so far out of sync with the season that their populations collapsed by like anywhere from 30 to 90% across many parts of Western and Central Europe. Now there's a happy ending to that story, because the really rapid warming that was occurring like latter half of April, first half of May, that was speeding this whole thing up, kind of paused. And the scientist that was studying this, a guy named Christian Both in the Netherlands, I had an opportunity to interview Dr. Both a few years ago, and he stressed it's not like climate change stopped. It's not like global warming stopped, but that unusually rapid warming at that period slowed, and it allowed the birds to catch up, because the birds that were arriving earlier, the ones that were programmed through their genes to arrive a little earlier than usual, were able to breed successfully and pass those genes on to the next generation. And within a matter of just 5 or 6 bird generations, they caught up.
Mm.
Now, if the climate starts really warming dramatically again during that period, they may fall behind again. But I think that's one of the things that we need to bear in mind is that, and I realize I'm giving a very long answer to this question. I'm sorry. Um, but I think it speaks to the resiliency of these birds. And I think that's important for us to keep in mind at a time when so much of the news that we hear about the environment, about birds, is grim. Um, there's, yeah, and Gary's making a really good point here about high Arctic breeders like Baird sandpipers are on such a tight timeline. And actually, that is one place in North America where we have seen phenological problems, and that's in places like the eastern and central Canadian Arctic, where late winter and early spring have become unusually cold and snowy compared to what they once
Mm.
were. And so birds like Hudsonian godwits and Baird sandpipers that are flying 9,000 miles back from southern South America, they arrive on time and like everything's still frozen and they got to wait and wait and wait. And then finally the snow melts and they can start to breed. And then bam, this like climactic switch gets flipped and you go from um, unusually cold, snowy late winter, early spring to unusually warm midsummer. And the insects on which these shorebird chicks depend, and they have to catch their own food. Mom and dad don't feed baby shorebirds. Those insects, like mosquitoes, emerge early and they're gone by the time the chicks are at their hungriest. And so,
Mm.
the successful reproductive rate for birds like Hudsonian godwit some years is like 6%. So it's a problem. So it's a Nancy, it's a huge issue. That, climate change. It as I said, it's hitting every moment of every day of every migratory bird's life to a greater or lesser extent. Oh my, I will try to be more succinct with the next question.
That was great. Thank you so much, Scott.
And succinct is not always the best. We're delighted
Okay,
for
all
your
right, okay,
we're delighted for your in-depth answer, actually.
okay. Well, thank you, Kat. That's very kind of you. My wife always says, "Oh, for God's sake, just stop talking before their eyes roll back in their head and they fall over." Um,
Uh, Other
Hi,
questions? And apologies, I'm hearing an echo. Let me try to fix that,
this is Trisha. May I ask a question?
please.
Yes.
Okay, and be as unsuccinct as you want to be. I could listen to you all night.
oh,
Um,
thank you.
I I have heard that not all birds migrate. Is that
Mhm.
true? Are there some birds that do not migrate?
Oh
And
yeah,
why would that
absolutely.
be?
Absolutely. Yep. There's many species of birds that don't migrate. And in fact, especially when you get into the tropics, that's really that's the norm rather than the exception. Most tropical birds are resident throughout their lives. Although there are some tropical birds that will, we've got elevational migrants, altitudinal migrants, where they'll move up, up into high elevations during the winter or during the summer and then drop down to a lower elevation, or will move across the landscape sort of following um, erratically available food supplies. There's a number of species of Amazonian birds, for example, that are bamboo forest specialists, and every so often the bamboo all dies like all at once, and they have to shift and move around. It's not really migration because it's not to and from. It's a little bit more wandering. But there's in fact you can learn a lot about bird migration by looking at the species that don't migrate. Willow ptarmigan up in the Arctic. My God, if I were living in, Churchill, Manitoba, and it's going to drop down to 40 below zero, and I wouldn't see the sun for 3 months, by God, I would migrate. But migration is incredibly dangerous. Um, those folks I was just talking about earlier today, and my colleagues from Alaska, we were doing an interview with somebody about a research paper we just published on Swainson's thrushes. And my colleague Evan made the point that about 85% of the annual mortality that birds suffer is during migration. Migration is incredibly dangerous for these birds, and particularly young birds on their first migration. This is one of the things I didn't get into with those bar-tailed godwits flying across the Pacific. I didn't mention that the adults leave weeks before the chicks do. So, they're like, even before the chicks are fully flighted, the adults are flying off, heading back down to Australasia. So these godwits who are going to fly across the Pacific Ocean for the first time are doing it on their own with a bunch of, it's like basically imagine a bunch of teenagers deciding we're going to fly to New Zealand for the next 11 days with no adult supervision. And I have often wondered, and I mean this absolutely seriously, I wish I knew what's going through the head of a young bar-tailed godwit on its first migration. It's never done this before. I mean, it's never been more than 2 miles from where it was born. And it takes off and it flies day after day after day after day after day across the biggest ocean on the planet. And it has to know at some level if it stops flying, it's dead. But I mean, does it wonder? Is it scared? Or does it just know I'm doing what I need to be doing right now? There's something deep in its bones that says, what I'm doing now is right. Um, it's just absolutely extraordinary.
Mm,
I can't imagine. I can't put myself in that bird's head. I wish I could.
mm. I think we are at time, Martha and Scott and all. I'm really sad about it though. I see we have a couple more questions. I wish we could just stay and continue hearing the amazing stories and knowledge that you are sharing tonight. Uh, but we probably should wrap up and let
Yeah.
folks have their evening, yourself included, Scott. Thank you so much, Martha. Do you have things you wanted to get to close out or uh, to let
All
folks
I can
know?
say is I'm just I just said wow to myself. Thank you so much, Scott.
Wow.
That was just
Well,
um
well,
Yeah.
thank you all for being very patient with my blathering, is all
Oh,
I can say. It's
if
so
I
much
could
fun.
Oh,
blather in
it's an
such a way.
incredible subject. Like you said, Scott, migration has always been something that I marvel at. Every time I see one thing I do when I hear my first wood thrush, for example, I just stop. Sometimes I cry and I
Yep.
just say, "Welcome
Yep.
back," and oh, I'm so glad you made
And
it.
exactly. And
And in the
what
fall, I'm saying, good luck. I know it's hard, but good luck and please come back. I'm
well,
constantly talking to them like that because I know
and
it's,
I feel the same way. I
yeah,
mean, one of the privileges that I've had over the years is to be able to work very intimately with these birds. Um, and we had a gray cheeked thrush on our steady site in Denali that we were able to track over the course of 5 breeding seasons, 5 migration cycles. And knew from the tracking data that this bird was going deep into the forests of southern Venezuela, one of the most remote jungles on Earth, and coming back up to one of the most remote Arctic wildernesses on the planet. It's such a privilege to look into the lives of those birds. It's great. So yeah, be out there, meet those birds with joy and gratitude in your hearts when they come back this spring because they have earned it.
Mm. Thank you
All
so
right.
much for this. I want to remind folks that we have one final Blind Bird or Bird-a-thon community conversation for this year, and that will be on April 14th, I believe. And we are going to be chatting, my friends, about how you can participate in the Blind Bird or Birdathon. We'll be sharing tips, tools, information for folks who will be joining the Blind Bird or Birdathon. And then there will be a wrap up opportunity afterwards, and we will be in touch certainly between now and then. Scott, thank you for sharing all of this. I know Martha and I talk often about the joy of migration and what it brings back to us. And so
Yeah.
it was fascinating to get to hear so much about why and how and to marvel with you at
Well,
migration.
thanks, and best of luck with the Blind Bird or Birdathon. And I feel really privileged to have even this small association with what you're doing. So
thank
thank you
you.
so
Thank
much.
you so much, Scott.
All
Thank you,
righty.
everyone. Have a wonderful rest of your evening. And I absolutely will be delighted to hopefully have you participate in other birdability events. You can find them at our website, birdability.org. Good night, all.
Good night.
Bye-bye.
Full speech. Jesse Manuel left parentheses slash alt F4. Zoom meeting.